Okay, Shupendu commented that I should. What? It's good to see you this way live. I don't want to do this here. I'm so. It's very hard for me to show this picture, and I've got my father's dog with me. Well, my father's no longer here. The dog is. He lasted a long, long time. Uh, you don't care. My father used to feed him beer and ice cream all the time. So here's what I'm going to do on this video. I cannot keep this thing on. It's just too distracting for me. This camera. How do I? Okay, after that introduction, sucked. This video is advanced, I think. Maybe for some of you uh, really smart people, it's not that advanced. If you aren't sure exactly what sculpting means, if you call a DCRS instead of a DSCR, please turn this thing off unless you really, really want to get tortured. The the idea here is going to be sculpting using sculpting together with a fixed fixed amount of debt in your capital structure and multiple debt issues. Sculpting, fixed debt issue, and then when we have the sculpting, we're not going to hold a flat DSCR. We're going to allow the DSCR to be nice and artistic, and maybe that's where the name sculpting came from, or whatever. We're going to show you how to do that. And while we do this, my friend Mike, who just got married, I can't say his last name. I've known him for 2 more years now, and we've never even shared. He's seen my picture in Zoom, but I've never seen his. He said, "Oh no, I want to see how to do a goal seek with UDF." So we're gonna, in the context of doing all this, we're gonna show you, because there's so many goal seeks involved. We're gonna show you how to make it so you don't have to press the stupid button all the time, and you can do a goal seek and another goal seek, and just use it like a sum function, a goal seek, okay? I'm already a little bit overdone here, okay? Here is the final result. The final result is I made a scenario, and our scenario has different little growth patterns, and maybe, just maybe, I can maybe copy our little graph and show you a couple of these scenarios. I'm not absolutely sure if this is going to work. So if you click on these scenarios, this is going to be, there are different scenarios with different project IRRs. We have a really high project IRR, and then we have a high project IRR. We have different amounts of debt, and the price or the EBITDA gives us different project IRRs. We have different debt tenors. We have different minimum DSCRs that the bank gives us, and we have different methods of shaping our DSCR. Now, I'm just going to do a few of these, but and then I think I'll interrupt this. This is just a little bit of the graph's supposed to be changing each time. It didn't work. I should have practiced that. Should always practice my videos first, okay? That sucked. And I'm gonna do something bad and just end it, okay? And now we better pick one more graph, okay? Notice how when I did this, by the way, every time you're doing this, you're doing a goal seek. Now this is just a curved. Does this work? If I just change that, Yeah, I get different patterns of debt service. And I forgot to tell you, I tried it with zero growth and positive growth. Now, here is the real finance. So if you're only interested in the finance, which perhaps you should be, if you have different cash flows and the whole really business of project finance, if you really step back and think about why it's interesting, why it's not just gimmicks, why it's not just kind of BS modeling. The whole business of project finance is trying to get an optimum amount of debt and, more important, repayment of debt that reflects the economics of a project. That's why, for example, oil project with a declining a revenue stream, because unless the oil price goes up, blah, blah, blah. When you have oil prices that go down, you want to make the debt service go down. It's a production payment loan. If it's a refinery, you want the repayment of debt on the refinery to reflect the volatility in the margins. And you want somebody from outside of your company to give you some financing to verify that you've not got a bullshit BS project. You've got something real. And if a bank does a good job, that's the big deal about a bank. You get the lower interest rate, you get a higher equity IRR, but it's a lot more meaningful. It's a lot deeper than that. Somebody from outside of your company is saying, yes, I want to put my money into your company. I'm going to let you be the owner. And then you've got verification. Now, when you do some of this curve sculpting, now this is only one dead issue. And if we try different patterns, so what I did is I made up basically the first one's flat. When it's 1,000 here, when we have, let's go up to, let's find some scenario to illustrate this. And now it's not supposed to actually mean all that much, but this is scenario number, let's go to scenario number 30. How's that? Okay, now I'm not going to talk about these drop-down boxes and this data table without the stupid goals, the stupid data table in Excel. It's not that stupid. So this is scenario 30. Now in scenario 30, we have a flat DSCR. And then if I change the shape of the DSCR, then I'm paying more of my debt off later and less off earlier, and my equity IRR from curve sculpting went from 10.55 to 11. And then if I do the next one, and I can do it even more, oh, that's getting a little aggressive. But when I get this one, this is scenario 32, and of course, I should have made a conditional formatting for you. Oh, this is the most extreme. Let's go back to the least extreme. This was scenario 29, excuse me, okay? In scenario 29, it's all boring and flat. We get 11% IRR. This is what the conditional formatting should do, but I've shown you that along so many times. And conditional formatting can mess you up, blah, 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 blah. Okay, so then we get it with the curve sculpting, we get a higher one. And then we increase the curvature by making our DSCR shape stop in 10 years, and then we get an even higher IRR. And then we make it even more extreme, and we do all of our stuff and put all our debt at the back and really reduce our debt service at the beginning, allow us to have a higher dividend, and then we can refinance whenever in the heck we want. So we can do some work to get this high. But now if you go to a different scenario, and perhaps this one, let's find one where it's less dramatic. If our well, this is not so bad. I'm looking at 6 here, and this one didn't work. I'll explain to you why it didn't work. We can't go too extreme with our goal seeks. Here's one where if we have a relatively high DSCR that the bank's allowing us, we can't get much of a boost. So sometimes you can get a lot of boost, and sometimes you can get a little. That's the idea. That's curve sculpting. It's only when the debt is fixed. If you're sizing the debt based on the DSCR and not running into the maximum debt to capital constraint, you're not going to have this problem. And this also, by the way, doesn't have my principal problem. This has a goal seek in, an automated goal seek. And this time, maybe this is one of these videos that I try to learn. It's German, and I listen to the videos at night to put me to sleep. So maybe this is going to be a long video that you can use to go to sleep. Okay, so this doesn't have multiple debt issues. I'm going to go through step by step some different cases. I'm going to show you, and I've done this before, I know, but I haven't gotten all the way to the end, ever. I know I haven't because I didn't know how to do it. Step number 1 is to show you if you have 2 different debt issues and you size the debt based on the cash flow. I don't even know the real terminology. If you size the debt based on a fixed debt to capital and a debt constraint, or just a DSCR constraint. That's what we're going to do. And we're going to show you that one way to do this, not the only way, one way to do this. Ooh, I hope I didn't mess up just now. One way to do this is to compute a debt IRR. Okay, and then we'll show you the simplest kind of method. Look at me doing a little bit of, let's get rid of a couple of these stupid lines so I can show this to you a little bit. This is when you have a fixed debt, when the debt to capital is fixed. Now, again, this is advanced. This is not for something you're going to have to talk about during an interview or anything else. This is if you want to get your mind screwed up a little bit like mine is. Now, there's a third method, and this method, it's a little bit small here right now, but this says, okay, what happens if we have a minimum DSCR, and the minimum DSCR is, let's say we have 400 of debt, and the minimum DSCR is 2, and, oh shit, 3. Let me put 3 here. And then I hope, well, what's supposed to be happening, I'm going to have to interrupt this stupid video, is that you just stop paying the debt. You sculpt the debt based on the minimum DSCR with 2 different debt issues. You can see it gets a little bit complicated, and I screwed it up. I might skip over that for this video right now. But basically what you do is you have 2 different debt issues and you want to stop the sculpting. You want to sculpt based on the DSCR with a fixed debt issue, and instead of trying to compute a new DSCR, oh my God, this is getting like crazy, a new DSCR, what you do instead is you compute I have to check that I'm recording this. Oh, I'm recording this. Okay, you compute a new DSCR instead of that. But the minimum, you might want to instead go down to the minimum and just pay off the debt early. Kind of stupid unless you're going to be refinancing. If you do some of this, it's okay, but then you've got to absolutely assume some refinancing in your model. So there's a lot of interplay, okay? That's enough of this one. And then we go to our curve sculpting method, and this time I'm doing it with I'm going to go to this one. Sorry, see, I've got too many of these things. I'm going to do the curve sculpting with the old-fashioned, not that old-fashioned, basically, okay, I hope it's not going to mess up, a goal seek. And that's kind of the one we just looked at, but this time, unlike that data table, that kind of flexible data table I just showed you, this time you'd have to run the curve goal seek each and every time. Not that big a deal. Can I do it here? No. Is this because I have a, oh no. Okay, well, let's do it by hand just to show you, okay, we're going to size our debt, and we're going to use always this formula that says size the debt from I've got to interpolate, good. Size the debt using the NPV of the cash flows, and I've got a high interest rate of 7%. And if I go to data and what if analysis and goal seek and set the difference to 0 by changing the first little DSCR up there, then it goes. So that's our goal seek method. And then the next method is to do the same sort of thing. This time I'm not sure if I have the same cash flows. Oh, maybe. Okay, and now if I want to change, let's say, the debt tenor and make the debt tenor 15, and maybe the problem here is that it's just a minute. FALSE. Okay, let's change it. Where did I change the debt tenor to 15? And then everything changes. Okay, Control Z. Let's take it away, and that's where we just did it here. So it's instead of doing this with the DSCR, that took a little bit more. We're going to show you how to make a dynamic goal seek. And I had thought in some stupid kind of way, oh, anybody can do a dynamic goal seek. Don't you know how to do a dynamic goal seek? And I made a video a long time ago, and I thought, okay, it's not a big deal. It should be standard part of the interview. That's a bunch of crap, of course. It's not that easy. It should be easy, but I managed to kind of mess it up. So we're going to be able to do these ones. Okay, good. It's changing. I'm getting some different answers. Some of them I don't like, and some of them aren't quite resolving. Oh, great. Okay, we'll keep going. That one did. All right, good. We'll show you how to make a dynamic goal seek. And then we have the final ultimate one. The final ultimate one, which is I'm going to walk through each and every one of these in order to get to this last one. And the last one, I really want to make this video faster here. I'm going to put a true in here. What I'm doing, by the way, I didn't even tell you, I'm turning on and off the goal seek. And in this case, we're going to use our curved sculpting where we change the DSCR over time, and it goes from 2 down to 1.3 by year 10. This took me so long. Is that difficult to really understand? It's going to go from 2.39 down to 1.3 in year 10. If I wanted to have it go down in year 9, I get a different answer. Okay, I'm going to leave it in year 10. Now, unlike the other one, this time we have 2 different debt issues, not one. And this is what drives you crazy. Now, the 2 different debt issues very well could have different debt tenors, 10 years. They could have different interest rates. They could have different other things, although those are the main things. Okay, but we want to make sure if we sculpt one of them in an extreme basis, we don't want to have that one that sculpts capture too much of the activity going on. You don't want to have one that gets this kind of curved sculpting here on an aggregate basis, and then have the second one being, let's have a boring old flat one. Well, that could happen, but that would mean that the capturing debt issue, and I don't know a better name for that. If you have a better name, I want to be like these millionaires in New York who get paid and don't have a house that's falling apart. I don't have a apartment that's falling apart because I make videos when I should be fixing holes in the roof. I knew how to. I replaced the toilet. This was really a big deal. I watched the video. Who cares about that? Where was I? That capturing that issue. They make new names. I don't know how to make a new name. Okay, whatever. I call that the capturing debt issue. You want both of them to have the same sort of pattern. That's what you really want. And if both of them are going to have the same sort of pattern, you if both of them have the same sort of pattern, then how do you make both of them have the same sort of pattern so they both kind of sculpt in the same way? So in this case, I had an example. And what did I have in my example? One of the issue, which I call the capturing debt issue, or the captured debt issue, at a 3% rate. Where's the other debt issue? Debt issue number 2 at a 10% rate. How do we make sure that the debt service flows in the same way? And it gets a little more difficult if they have a different debt tenor. Now, what we have to do then, we don't have to do anything. What we could do, how's that? That's a better, because maybe there's a better solution to this. You understand how just trying to express this problem, trying to just express this problem is difficult enough. Now, the method I came up with, and that's why it's really good to have this goal seek. Otherwise, I'm gonna do a whole bunch of goal seeks anyway. And you'd want to put all these goal seeks together and just have it optimize. You could have an optimize button. Remember, I have nothing against any more copy pastes. Nothing against them. And if you've got a small model and a simple model, why not? What the heck? Okay, I remember in Russia somebody said, well, you can attach the copy paste to your little drop down button. That's good enough, isn't it? Now, when you have different interest rates, what you can do is you can work through sculpting based on the formula, which is debt service divided by DSCR, but you multiply the sculpted debt issue. You multiply that sculpted the sculpted debt service rather by a percentage. So in this case, we take our curved debt sculpting up here. We take our curved debt sculpting, and we use we're not finished with it. Once we've done the cash flow divided by the DSCR, we multiply it by a factor. Now, in this case, the debt was 40%, and this factor is not exactly 40%. If this interest rate, and notice I didn't do my coloring, if this interest rate would be exactly the same as the other interest rate, if the tenor and the interest rate are exactly the same, and where's my interest rate? So I'm going to make the issue 2 have this interest rate, issue 1 have the other interest rate, and before I do this, I switched it off here. I'm going to explain why I had to switch off the goal seek. Now, if you do that, then we're going to have to recompute a debt IRR. We're going to have to recompute a goal seek, and we go around and around, and we keep on recomputing the goal seek here. Where's our difference? Just a minute. Okay, the PV here. This PV worked, and this interest rate was 3% on this one. It was 3% on this one, and we get. This should have been 42. I'm getting a debt IRR. I've got to go around, and then I've got to go around this one, and then I've got to go around this one, and that's even with a goal seek. And when we finally get that, we're going to get exactly that the debt service. Oh, look, you have to go around and around. Can you imagine all the circular reference problems? And you can imagine if you do this, wouldn't it be nicer to put all of these things in a formula. I still don't quite have it, but I basically have it. We get 40%. That's from our goal seek. If this is here, we got exactly 40%, which is the percent of the second issue is 40% of the debt. The other one's 60%. We have to do it a couple more times, and then we'll eventually get it. Now, if you have a different interest rate or a different tenor, this 40% won't be the same. And what I understand from Hetty is in her real projects, if she had a tenor, let's say, of 20 years, she'd sculpt it to get it down so the DSCR would go down to the minimum by 10 years. Is this complicated enough? Is this complicated enough? I think it is. Now, what I'm going to do now, I hope I've introduced the issue all right. And I'm going to go through one by one how to get there, including the automated goal seek, so you can skip forward on the video and try to find that. So the first thing I did, we just did this. We put a 2% growth rate, and you know, here's what I can't understand. For you Excel bureaucrats, and I'm so mad at my friend, my other friend, I'm not going to say who. He used to be kind of a creative person, and he's become a complete Excel bureaucrat. And it's so sad. Because we got to put spaces. Whenever we do our typing, I can type so fast, I can do the spaces. And I'm not going to ever use Shift Control R anymore because I'm so good. I got to open my generic macros because I'm so good. I can whiz bang around and I can go, okay, whatever. You know what I mean. Yeah, I can go control right, down, up, back, and I can do it so fast you can't even see it. And that's what good Excel is about. What a bunch of good Excel, maybe, yeah, but not good modeling. When you don't understand Modigliani and Miller, Mr. Merton Miller, who said split the companies between the financing and the non-financing instead of mixing up a cash flow waterfall at the top, and instead of not even showing the project IRR first, instead of not first understanding the economics of the project. Oh my God. Okay, I got to calm down. That's why I'm not showing my face, because it's getting all red. So now we have an aggregate DSCR, and we've got to split those into two issues. Now, the first thing we can do is figure out the debt size based on our aggregate debt thing. And that's okay. It's all easy. But you remember that the key thing behind all of this stuff, I hope I probably just messed up something. The key thing behind everything is to put a PV of debt service. And that PV of debt service is the amount of debt. That's the first thing to do in any of these things. And in a PV, you need debt IRR for PV. We need a debt IRR. Now, if we have one issue, that's really easy. We just use this one. Or if it's a second issue, we use this one. But now we need some kind of weighted average. And that's where it gets painful. And I've tried to do this. And I say we have a capturing debt issue and a non-capturing debt issue. For the capturing debt issue, we take the DSCR and divide it by the debt service in 1 plus 2. And the debt service, you're right. DSCR in aggregate is the CFADS, and then I have to keep going around and remember that the debt service for the capturing one is the cash flow divided by the DSCR, the total aggregate DSCR minus 2. So we'll go down here. Notice that this capturing is down here, and that was, we take use that formula. The easy part of this is getting the debt service for the second one. Now we want the DSCR to be nice and boring and flat. And if it's boring and flat, we can use my LLCR method, where you take the NPV. I don't know why I did that. of this one. And maybe we should put it over here so we can be clear on what it is. And that's this one. And then we just say, okay, take this LLCR, which let's put this as 30%. And then the LLCR is really high, but who cares? This LLCR, and I need to maybe be more explicit about this one. This is the debt amount. Now, if we have the debt amount, which is just 30% of our total, and we have the PV of the debt service. Now, if you have a different tenor, this PV would only be over 10 years or 5 years or whatever. So that has to be reflected as well. And then you get the LLCR, and you take that LLCR, the cash flow divided by the LLCR. And if you don't believe it really works, you can put NPV at this interest rate of this amount. Okay, this is going to be a long video, and I'm not going to stop. I'm sorry, I'm not going to stop on this one. Okay, and I'm going to be relaxed. You know, I'm so nervous because I think, oh, these people hate long videos, and I should be able to make a short video, and I can't. I'm lazy. So I notice I didn't put my, oh no, I didn't put my spaces here. I think, is this a space? Oh, I think that's a space. Good. Oh, I followed the bureaucratic standards now. Oh, good. Okay. Now, so then once I have this debt issue, then I can apply our rules down here, and we can get the multiple debt sculpting. That's all easy. And then I do the same thing, and I get the present value of the debt service. Now, the theme in this one should be maybe, and maybe, is this a rule? You have to put a little space there? Maybe. Then the rule is, how do we get this rate, this whole rate? That was the key. Now, I could have also done a goal seek. I could have said, let's change the interest rate in order for the in order that the difference between the two equals 0. I think I changed the interest rate, right? Or do I change the debt size? Okay, I'm not doing it that way anyway. It's actually an easier way to do it, but whatever. You have to understand the capturing. Total, and this one I should have said here, total debt using PV. Not the total debt up here. Okay, and maybe we should have put these over here to make it a little cleaner. Shouldn't we have done this? And shouldn't I put it over here? And then I can be all very bureaucratic. And then this one doesn't have a range name right now. But this is the difference. So something is wrong because we were supposed to get 600 of debt, 607, and we got too much. And the difference is because of this IRR. And so what you do is total debt cash flow using PV, using this one, and not this one. I have gone crazy. I have wasted so much time and saying, which one should I use? That one. And then we have a negative number and a positive number, and that gives us an IRR. And this debt IRR, when you're having multiple issues, is extremely important. That debt IRR allows you, the debt, you know, I am going to make 2 different videos, I think, because I'm going to go through I can't, that's going to be too long. Okay, and what I can do is just take this debt IRR, copy it, paste special as values, and then I get a difference. And then that fixed debt goes up here. That's a copy paste. And then I can copy this, paste special as values, and then I get a smaller one. And then I can just hit my copy and paste and get it resolved. And that's the sculpted debt issue. That's the first one. And now the reason I'm saying that is if we go all the way to the end here, remember, we did our sculpting and we did all of that. Remember this one, I'm just thinking while I'm doing it. In this one, we had this problem where we had to go around and do a goal seek on this one because we had two different debt issues. And in order to get our and when we did our aggregate debt issue and computed this little 40%, and we had a different, oh shit, I'm trying to make the video. I think I'll be able to do it. Okay. You know, if I change this to 10%, okay, then it's the same sort of issue. We got to get a new debt IRR, but when we get a new debt IRR, this one changes. Oh, God. And then we have to go around and around. And this time the goal seek is a little more difficult, but you understand that it's got the same sort of general kind of problem. Okay. So let's go to the second one, which is really a easier problem to solve, and that's where we have the fixed debt issue amount, and we use the LLCR to compute that. Now, I've done that many times, many, probably 2 times. Why I have a bold here, I don't quite know. But this time we're saying we have the same sort of cash flow. Okay, we have our 2%. I'm going to leave it that. And then we left an aggregate DSCR in, but this aggregate DSCR is basically meaningless. The only time it would come in to play is when you don't use this method and you want to say, oh no, I would like to pay off my debt early. Not like this. I'd like to pay off my debt early, and I'd like to use the other method with an aggregate instead of this one. Okay. By the way, I changed something in the... No, I can't show you this now. So we have the same sort of thing. This time, I computed a debt IRR, but there's no goal seek. You don't have to do it because you're defining the debt up here, and this calculation is really, really easy because this debt, by definition, is going to just be allocated between one debt issue and another debt issue. No big deal. Okay, and then we have one debt issue which has got a really high interest rate, and another debt issue which has got a lower debt interest. And what we do is almost the same thing. Let's just review it. You take the present value of the debt service at the interest rate for the issue. You look at how much the issue is itself, and you find the LLCR, which is the PV of the CFADS at interest rate for issue. And then you go to the second one, and why is this always like this? Must be a reason. You do the second thing, you do it exactly the same for the second one, you get a number. And if you notice, I did it the third. I kind of went 3 LLCRs. LLCR number 1, LLCR number 2, LLCR number 3. Now, this one, I just divided it by. I think, let me just screw up again probably. But if I would have taken this total CFADS divided by this issue, oh no, this total CFADS, not the, I keep dividing it by the debt service rather than that, and then I take a minus on this one, so that's our aggregate method, I get exactly the same result. And at the end of the day, I get a DSCR that's above this this LLCR. And in fact, that's basically that is the basic fact that when the LLCR is above the minimum DSCR, you can't put this minimum DSCR and size the debt from the minimum DSCR. It's like the debt to capital constraint is going to be in place when this is bigger than this. Again, I should have been able to say it a little bit better, but I don't have my project IRR and everything else. And then, just like before, we needed this one. We needed this one, this debt IRR to be here because I needed that to compute this. I didn't actually need this, did I? I was wrong. I did not need that but it's a nice little proof. Okay. I didn't absolutely need it, but when we compute it, it's really easy. We just take the total DSCR of 1 plus 2, we take the total debt, we compute the debt IRR, and we use it. So it's a good example of showing the debt IRR, but you don't need it. So now let's skip. I'm going to skip this minimum thing because I kind of messed it up. Let's skip to this issue where we have a curved DSCR, and this time we have a fixed debt issue. And I have made a different video about this. And when I made a different video about this, I normally would say if we have a debt tenor of 15, let's put another debt, let's put this ending value to be the same as the debt tenor. Okay, and let's make sure that our minimum DSCR that we put in here, 1.3, that this minimum DSCR comes from here. Now, the reason I've done this is because of the next video that I'm going to make. And in the next video I'm going to make, instead of doing this with a goal seek, I'm going to do this with a UDF that runs the goal seek. Okay, so but this time you notice this is different. Now, right here, I hope I've shown you that if we're aiming for 600 of debt, and I hope I've ingrained in your, I hope you're not an Excel bureaucrat. I really hope you instead think about the finance. I really, really, really hope that that's the case. Instead of almost running to your Excel, let's start just putting a bunch of 1,000 different formulas and you think through the problems. So here's our CFADS, which is going up, and I did this time to get a 9% project IRR. And this is when this would kind of typically apply, is when you have a relatively high IRR. And then we have a DSCR that goes down, alternate F1 maybe. Why? Maybe I should have put this. So we have a DSCR that goes down, and the DSCR that goes down is next to the debt service that goes up. And I'm not going to put the debt service in the graph. Okay. Now, but this doesn't match. So the big thing we can do is make a little table and then use this interpolate function. And I still, I cannot believe, maybe the Excel does not have this yet. Why out of all these little functions I make, this is by far the most important. And now if you want to get this function into your Excel, open the generic macros that nobody uses ever, Even in my classes, everybody says, I'm so fancy in Excel. I don't want to have to use this. I can do all my coloring myself because that's the most important thing in Excel is to color your sheets. That's the most important thing. And by God, you could never have a little black thing up the top because then if you ever have to print out something, you can't see the printing. Who in the hell has printed out an Excel sheet forever? My God, these fucking, I'm sorry, I go a little crazy. I'm just being told I'm crazy. Well, I am crazy. Sit here and do Excel all your life. Your mind is not going to get crazy? Okay, so you open the generic macros, and then you go to import functions, and then you just put it right here. And you just put this here. Now, I'm not going to do it now because I've already got it. And then you click on this one and it's finished. That's all you do. And then you get the one of the functions. You build your own function and you can put it in yourself, modify it, do whatever you want. Be a little bit creative here. Got to calm down. Okay. Now, this video is not for children, by the way. It's not supposed to be for children. Okay, now, I always mark that when I make the videos because sometimes I accidentally swear. But it's okay. Now, when we do this, when we make this a curved DSCR like this, okay, this is the number. And I can use this number with the interpolate. So the way the interpolate works is you put equal in, just like a lookup, but this time you put interpolate, lookup, and you can do it with a linear approach or a growth approach. And you go up to your number and you say, I want to then look up on the entire line. And that's another thing I go crazy about, but I'm calming down right now, so I'm not going to go crazy about that. Well, all these idiots who say, oh, you're not allowed to do that. Some wonderful person said, oh, my boss doesn't allow me to do that. It doesn't. If it's an old wives' tale, which I shouldn't say old wives' tale, that's a bad, politically incorrect thing to say because wives don't make bad tales or something like that. But that used to be said, and it's an old wives' tale that you cannot use this whole line as long as you don't have any junk over here. Okay, we all know that. Okay, and then you take once you have the curved sculpting, you take your CFADS divided by this curved DSCR. It's not very different than the rest of them. And then the only thing you have to do is compute the NPV. Now, I have done it so many different times where I said, no, what happens is the interest rate changes. Of course, you have to compute a compound factor and take the sum product and divide it out and all that stuff. Okay, or, whatever, do the NPV with compounding, okay? My friend Thomas, he's really good. He gets it, all this stuff. And then what you can do is do a goal seek. Because if I change this to 2, then I'm going to get, this might not, I might have picked a bad one, which is kind of good. If I change this to 10, if I change this to 1.44, I'm not getting a negative because I put this in. I'm going to have to put a lower DSCR at the end. I'm going to put 1.1 here. And then I'm going to put this as, I need to get this, the PV down. Let me just think about this. If I got to get the PV down, we're getting too low of a PV, so maybe I could put 1.5 here. And I did it the wrong way, 1.2. And then it's negative. And if I put 1.3, then it's going to be positive. And if I put 1.31, it's going to go around. Now, this is exactly what I did. And basically, when you're going to make a goal seek that's automated, you're going to keep changing This is what you're changing in the goal seek. And you could imagine writing a little program to do exactly this. And then you've got a criteria, which is this difference. And this difference all comes from the PV. So if you don't get that the PV of the debt service is the amount of the debt you're aiming for, don't do this. Really, don't do this. And then you have a curved DSCR and we have an equity IRR. Now, I could do this a different way. I could put 10,000 here. And if I put 10,000 in the interpolate function, it's basically going to be the same. There's a tiny little bit of curvature here. And then I could, this is too high. And if I computed down here, the LLCR, did I compute the LLCR? The LLCR is 1.21. If I put 1.21 and just hold a flat 1.21 here, if I just do that, then, okay, it's not exactly flat. Well, maybe, what if I put a few extra zeros on here? Will it get? No, it doesn't even. Eventually, it doesn't help. I'll just put 1,000 here because that's what I did. Okay, so all right, this tiny little bit of difference is because of this. I could do a goal seek on this too. Okay, but here's what I wanted to show you, that the IRR is here. If I did this and instead put 15 here, and then instead put 1.32, we were something like that up here, oh, 1.33. Okay. The IRR is 10.43 with 1.21. It's not so, oh, whoops. Not 1.21. Oh. And put this to be 1,000. Then the IRR is going down to 1.36. Okay? Maybe I should put this LLCR the way I actually computed. Okay? I was a little bit freaked out just now because I thought the IRR was going in the wrong way, which would invalidate everything I'm doing. But you can see you can get a boost in the IRR. Now let's do this with 400 of debt instead of 600. If we put 400 of debt in and we have a LLCR, we get 9.71. But if I put in the closing value of 15 and I put now my 1.4, 1.6, 2, 3, I'm doing a goal seek by hand, which I shouldn't do. You can be irritated with me and say, why am I not doing an automated goal seek? And what was my, so let's look at our IRR, what it was before. I hope you're staring at this number. Okay, with the LLCR, we had a 9.71. Let's write that down. Equity IRR 9.71%. Okay, if I put this tenor in, and then we do it to be, what was that, 3.5, whoops, not 3,5, 3.4. 3.45. Okay, let's do a goal seek. Data. What if analysis? Goal seek. We set this to 0. Okay, which you should always do with a goal seek. And to get there, we change the first one. And we get there. Okay, and now the IRR went to 9.89. Not a dramatic boost in the IRR. You can go further. There's no reason we have to really necessarily stop here. Now, what the bank might look at is that the average life of your debt, and they might have some constraints. And frankly, I don't know exactly where they get these constraints from. There must be some internal kind of calculation of RORAC or RAROC or and all that stuff that puts the average life in. But if we are willing to take a shorter average life, we can put this end value instead of 15, we can put it to 7. And what happens then is we hit the number by year 7. And notice that we don't get this. And then we put our, what happened here? Did I put 2 of these things here? Okay. Now, well, it's higher, but we have a negative NPV, so we've got to do a data, and we do a what-if analysis, and we make a goal seek, and we set this value to 0 by changing the initial thing here again. This time it took a little bit longer. It was struggling a little bit. And then we get 10.13, so we can do this. And now we're starting to get a ridiculously high DSCR and a ridiculously low thing, but that's okay. What the heck? All right. And if we go too much further, our goal seek won't work. Let's try to make it 5. I bet you our goal seek won't work then. Okay. And one more time, I'm going to save the file. Probably it's going to go to one of these blow up goal seeks. And by the way, that's what you have to be worried about when you write your own goal seek function. You have to be worried that that's not going to work. Now, look, I'm getting 1,000. Oh, good. I almost wanted that. Okay. Luckily, I can cancel that. Okay. So there's a limit. Now, when I showed you the very, very first thing we did, which is these scenarios, sometimes I hit that limit with our goal seek, and I just went through the iterations, and I was able to stop it instead of going through that crap. Okay. So that's the issue. Now, if we want to, the bigger, so if we let's make our tenor be 20 years. So we've got a longer, whoops, I'm in the wrong one. I hope let's make our tenor be, how many years did we, let's go crazy. I have 35 years, 33 years. So let's make our tenor, oh, the dog's coming back. Let's make our tenor be 30 years. And this time, I'm going to leave a really small IRR in here. Okay. And 5 won't work, so let's put 7. Let's see if we can do it with 7. Let's see what happens, and let's see what happens to the thing now. I guess my goal seek doesn't work. I guess I didn't make a macro. I should have made a macro to do it, but whatever. Data, and you can say, well, if you make a macro, isn't that just about as good? And that's probably true. That's the most common macro you'll ever make. And I told you that when I was it was in the 1990s, sometimes when I made my first macro, it's like when you remember something bad happening in your life, you can remember the first time you ever did something where you were sitting. I was sitting on this old yellow couch when I was alone. Oh, it's great. Oh man, was that a good memory when I made my first macro. Okay, and then we're going to get there by changing this one. And then is it getting there? No, it's not getting there. I can't do it with 7. Let's do it with 10. Okay, I should have taken that. Let's do a data what-if analysis. I'm almost making an argument for doing our goal seek with a function because you can test things like that. Did I do that? Right? 29. Okay. Is it getting there? It's going really slowly. Why is it taking so? Oh no, it can't get there even. Oh no, well maybe I gotta put 15 in there. Okay, this is making a better argument for making a UDF, which is the next video, with a goal sake. Okay. Oh, I shouldn't be. This one looks like it might work. Finally. Oh, but we got a ridiculously high number again. Okay, whatever. I've got an average life of 42 years. That's not going to work. Oh, finally. Oh, come on. I really want to stop this video now, and I can't. Oh, I want to stop it so bad. I want you to turn it off so badly. You can do this yourself. This is going to be in the. Oh, please don't be so bad. I'm surprised that last one even worked. And what happened? Okay, finally, we got something. So our average life is really long. Okay, okay. And did I do something wrong? It sounds like it's too long because I've got negative repayment and then I've got positive repayment, and the bank might not like that. But I get a 12% IRR. So let's remember that. So if we really try to optimize our sculpting and try to push the bank, and of course you're going to have to negotiate all of this stuff with the bank, and of course you can imagine a gigantic monster model when you try to do this, how it's going to mess up. And then after we do this, let's put our 1,000 here, and let's put our LLCR here. And let's see, now our average life went to 23. Okay, still not so long. But then our IRR was 10.38. And you can see that difference in IRR when I made the debt tenor longer, when I make this DSCR shorter, when I make this smaller, when I put more of a constraint on the debt to capital, that's when this curved sculpting really makes a difference. So I'm saving this file and stopping this video. If I can stop it.